skittish about math, I'm going to ask you to enjoy it. Enjoy the learning. Enjoy the learning with your child. Laugh about mistakes. Fix them. But mistakes are a really big part of learning, and they're okay. And if you're feeling timid or whatever, I'm going to ask you to fake it until you start liking it. Because you will. You're going to give it that chance. It's going to become part of the joy of learning with your child. But that's really, really important. Another thing is your teacher is your ally. They send home notes weekly. They send home strategy letters for every single unit. Please read them. They'll help you to know what your child is doing. We are not asking you to be their sole math teacher at home or an alternate math teacher at home. We would really ask you to support us, that you've chosen this school for your children and you trust us that we know what we're doing and we are developing their math from conceptual to representational to abstract. Please don't jump to the abstract that you're comfortable with. I understand you're comfortable with it, but you probably don't actually remember what you were being taught in third grade specifically. You know it now, but please let us develop it so that your child can understand it. You guys are the first group that I'm totally uncomfortable. You see no manipulatives in front of you. That is just so out of my character. But if you've been with me for 2 years in first grade and second grade, I told you that they would disappear. They've worked with them really well. In the classroom, your kids would have manipulatives to support what they already know. But the main learning at this point is we are getting onto the representational. Three-digit addition column traditional method really is a fourth grade standard. There will be kids this year who see it because of the way we've led them to look at it and understand it, that are going to figure out that column method all on their own for the first time they see it. Would you please wait and let that develop? And the other thing about what your teachers send home, the shortest way to have a conversation with your child is to say, how was your day? Fine. Yet, if your teacher has sent home saying, we are working with, number bonds today, that's not a good one for third grade. We're working with the understanding the tape diagram in working with word problems. You've got buzzwords. We call it scaffolding. You're handing them a link to what to talk to you about. And then they're going to have something to say. It's not that they don't have it, but you're just helping them get there. It's like, oh, that's what she wants to hear. And some of them, if I hurry up and talk about that, I'll get to go out and play football. But we do. We want to have those conversations. We want to know where our children are in their learning. So those are my two big things that I start every time with, and that will never change. And it's going to be true for your child through calculus. Then they move away to calculus. Then it's got the whole Skype call. We're going to start today with some mental math. I don't know if your children, a question you could be asking them, we've really instituted number talks. It's where the kids sit with the teacher, they're given problems, they do not have pencil or paper or whiteboard. We are trying to get back to a strategy of not reaching for your iPhone to flip open your calculator. Our brains are really capable of lots and lots of arithmetic. I was told to add, 27 plus 54 to be accurate, I better pull out a paper, I better write it down, it better be column method, I better write it all in the right place, where actually there's lots of strategies where I could have done it in my head and been done like that. Having that ability makes for flexible mathematicians. Let me show you. You all have the packet. The quick thing is, here on the packet, this is my email. It follows the standard form of ASD's email. The one underneath it, the ASD Parent Math Resources, is a website. It is hosted by Live Binders, and I put up copies of what we're doing today. There's a videotape running on the screen. It catches our voices. I will put up a blank copy of this packet, and I will also put up a copy of the packet with answers. We will not get to everything in here today. I put lots. It kind of depends on the questions that come up. It also, I could claim it to be homework that you could go home and do the extra ones, but if you want to see how they could be done, these will be put up. It won't be till next week. So this is a live, if you Google ASD Parent Math Resources, it should come up, but that live binders might be with it. Please accept it, that's the hosting site. If you have troubles, you can always email me and then I can send it to you and then you can just click on it. It's a horrible URL. Okay, so let's take a look. I'm going to ask all pencils down. This is what we're asking your kids to do. In this particular unit, they're applying their addition and subtraction skills to measurement. We're not asking them to convert. We're not asking them, they're not even particularly measuring things. I mean, they might for a project, but the idea is that we're taking the math that we teach them, and they want to say, why do we need to know this? And this is kind of why they might need to. This is a real life application. So the first one says 46 milliliters plus 5 milliliters. What's the answer? How do you know? How could you prove that to me? Okay, I'm sorry, I'm gonna have to be a teacher here. I'll only hear these two ladies if I don't actually take hands. So let's go with you, you're here. How did you do that?
Well, 4 plus 6 is -50, and then you have one more.
Okay, I'm gonna see if I catch this. Did you break up the 5 into 1 plus
Yes.
4? Okay.
Yes, sorry.
And this is how we write it down. No, we're just getting started here. So now I can do 46 plus 1, that equals 50, and that equals 50. Oh, I'm sorry, this is plus,
One other side.
okay, here. There we go. There we go. These are what we're asking the kids to do. We're writing this down. We're introducing, these are the properties in math. We don't talk about it until a child asks about the parentheses. Honestly, we're using this method of writing down into first grade. It makes total sense to the kids. So we're exposing them. We're not teaching, we're not testing to it, but we're exposing it to them, and their brains completely accept it. So what did she do? She broke apart her 5 into 1 and 4, and then rearranged the problem so she could add an improvement. Did anybody do it another way?
I mean, I do, just because I'm used to
The column method. You just kind of did that. And absolutely, you did. That's honest. At this point, some kids are going to say, I just knew it. They did. They have their math facts so strong, and they've got flexible brains, and I accept that on this type problem. We're going to get to other problems where I just knew it isn't really the truth. I mean, you can't just know it. You have to have done something, even though you were able to do it easily in your head. Okay, the next one, 39 plus 8. Okay, how did you do it?
The same thing, we break 8 to 1 plus 7.
This used to be considered a difficult problem because of regrouping. We made it difficult by telling kids they had to bind things together and then regroup and share it, instead of just the idea of sharing the one. It's called compensation. I can take one from one number, give it to the other, and I've got an equal strategy. I want to change this one to... Would you turn and talk to your partner? Why do you think I changed this problem if I was doing this with kids?
And when they see a big number, 3-digit number, so they only this can or is that this is what add a small number to remember.
We teach now.
Yeah, and I would say I made a mistake on this set of problems. I don't want to teach the kids that it's always the first number plus the second number. I want them thinking about them out and making purposeful choices. Time and time again, the kids will figure out it's easier to start with the bigger number, break apart the smaller number, and add it to it. So, then they're seeing this, oh, so this is really equal to 125 plus 7 grams. We are back to another mathematical property, a commutative property that's quite important. And they're seeing it and they're comfortable with it. We do not label it. I might label it if a child asked. I might label it, but I'm never going to talk about it just in those terms. So this is the idea of our number talks. We're getting kids to understand that they can use the calculator in their head. It was the original calculator, and it's always with them, and it usually has enough battery to keep going. Any questions about mental math? Yeah?
I have a question about the units. I mean, why do you put units? Why don't you just add in 46 plus 5?
Honestly, in a number talk, it wouldn't have units. The particular unit they're studying, they're using it within measurement, so we're trying to show them. I mean, 6 plus 5, we call them naked numbers. It's a math problem. The kids then go, why do I need to use this? You'll see as the word problem comes along, we're going to start talking about doctors. We're going to start talking about measurement of, not feet and inches, but centimeters, because somebody's building something. So that's just why they're there. They're there to show the practicality. It's not about the math. They have done measurement in other times, but this particular, they have done conversions of measurement at another time. This particular unit is more about addition and subtraction.
So at this point, we shouldn't be worried that we put, for example, 7 grams plus 125 liters. That it gives the unit.
In this particular unit, we wouldn't do that. And we're not asking them, I'm just not a metric person, I'm sorry, I'm American. We wouldn't ask them like 98 centimeters plus 98 centimeters, how many meters does it equal? We would accept the answer completely in centimeters. So this is not a conversion unit. They will have one after they know how to do the addition. Yeah. So we wouldn't be confusing them by putting different measurement systems or measurements.
And if you see them put in different units, will you correct them?
Well, are they simply just changing this themselves to?
I'm just saying, if kids and you see it, then like they start putting it on, should we be correcting them?
I guess I'm a little confused. They shouldn't be seeing it by something given by the teacher. There shouldn't be it. I mean, if they're just picking it up wrong, yeah, I'd say, is that really what the question asks? If they're just, yeah, I would just always ask them, is that what the question is looking for? Okay. So the next part becomes, would you do these mental math or would you pull out a piece of paper? 24 centimeters plus 36 centimeters. 60. I mean, I see people writing, that's fine. It's what I was taught to do. By the end of 3rd grade or the end of this unit, I would expect that most kids are doing this with mental math. How about the next one? 562 plus 180. Yeah? What does yeah mean?
Yes.
This is where we're going to start seeing the class split. They can add the 100. They can go 562 to 662. Many of them would then break up the 80 into 40 and 40. But a lot of them at that point, they would need to have a number line or doing something on paper to keep track of it. And the last one. Yeah, if we want to make sure we're accurate, honestly, I'm going to do that on paper or with my calculator. Calculators came up. We don't particularly use calculators really until kids are strong in their arithmetic, which is at about 5th grade. And I would even say barely by 5th grade. We're still teaching the strategies and the understanding of arithmetic. Will there be time that calculators come out in the class? Yes, for a number of very good reasons. One is sheer engagement. Kids feel like they're really cool and they're big mathematicians because they're using it. We're not trying to teach them that. We might let them check their homework with it. I've used it where we have races of who's faster, the calculator or the mental math, to prove to them that the mental math is faster. So yes, your kids will be holding on to calculators, or they will be touching them, but they're not a heavily used tool. And until third grade, where they're estimating, I really don't think kids should be using calculators because they are so easy to put in the problem incorrectly. And if they haven't made an estimate prior to that, they're not going to notice it, and they're going to accept that answer that could be wildly off. But because to them, they did it on a calculator, it's right. Now, third grade is learning estimation this unit, so we're getting to that point. Okay, next page. This is really large. Arithmetic is the calculations and adding and the subtracting. We now talk about your child needs to be a mathematician, and that's knowing when to use the arithmetic, knowing how to take a real life problem and understand it, and then solve it with the computation or solve it with the arithmetic. That is why if you have older kids, you may have noticed there are a lot more word problems and there are a lot more problem solving. And I say we, I mean the world in mathematics, except maybe the Japanese who were doing it right the entire time. We got too far skewed over to just the procedures, even if they were really good ways of thinking about it. But if they don't know when and how to apply it, and if they can't visualize how to apply it, it's not really worth a lot. I could quote some algorithms that you use in algebra and calculus, and I have no idea how to use them. They're not really of use to me. So, we talk a lot about visualizing the math. We'll be hearing the word modeling. Modeling is the way that the kids prove to us that they understand the question. Kids like to look at this and go, I don't really want to read, I see two numbers, I'm just going to add them up and give them an answer. It might be right, it might be very wrong. So we are asking your kids to explain their thinking, and we're asking them to show us that they understand the question. So let's look at this. Jamal had a piece of rope, his brother cut off 47 centimeters and took it. Now Jamal only has 68 centimeters left. How long was Jamal's rope before his brother cut it? So I want to take a look at what is this question telling me. So there's a piece of rope. This is called a tape diagram. It's a long rectangular box that we figure out how to demonstrate what we know. I got a piece of rope. My brother cut off 47. I'm going to write that. Now Jamal only has 68 centimeters left. How long was Jamal's rope before his brother cut it? And there's my question. If I receive that from a child, I know they understand what this problem is about. They may go about and do the arithmetic wrong after this, but in the world of problem solving, that's two different grades. Assessments are to help us keep teaching and help kids know where they are. But I know that this child, I need to work, if they got it wrong, I need to work on the arithmetic. This word here makes a lot of kids do subtraction. Please do not go through and tell kids that they can read and look for highlighted words and that tells them what to do. It's not true. It works sometimes, but not all the time, so that's not good. So now we have the understanding. I know that this is an addition problem because I'm trying to find my total. We do use the term part whole, part total. We've been using it since first grade. In first grade, not that they would have these numbers, they could have demonstrated the problem like this. It's not likely because of the takeaway issue of it, but it's still the part whole, and if a child did this for me, I'd be happy. I can't really think of many other ways that they would demonstrate understanding this. There may be. We look at them. The tape diagram is just incredibly useful, but it's not the only one, and we accept what kids do if we can visibly look at it and understand it quickly. That's the point of it. So the different methods, and the reason you don't have manipulatives on your table. By third grade, we might expect to see 60 plus 8, 40 plus 7. That would give me 60 plus 40 equals 100. 7 plus 8 equals 15. And I have 115, double check, centimeters left. What I'm going to do is, on each problem, I'm going to demonstrate different ways where they could show me their thinking on their addition. I'm not going to show you all of them on each problem. There is not, your child needs to do it the way they understand it. There is a progression of pictorial to more representational. This child is using place value to break it apart. This is where we're definitely moving in third grade. I am going to draw some pictures that you'll probably recognize from second grade. And we start showing the kids, here's the picture, how does the picture relate to the numbers? And as I said, no, last year they had all the discs in front of them on their table. This answer statement is incredibly valuable. They know that kids like to just grab numbers. If the child has to answer, make an answer statement, they have to go back to the original problem to figure out what the question was. That helps them know, one, they're answering the correct question. And secondly, there's a way of, it's like a double check, is this answer reasonable? So if I was looking for a total that somehow lost my 100 and had 15 centimeters, and I'm going back here, it's that one last opportunity to double check. It's like, well, wait a minute, that doesn't make any sense if I'm trying to find two pieces together and my answer is smaller than my other two. Now, most children don't think of it remotely that thoroughly, but it does help them. And it's more about, are they answering the correct answer? Okay. The Goldfish Aquarium at South Pastor was 189 liters of water. The Guppy Aquarium was 94 more liters of water than the Goldfish Aquarium. How many liters of water are there in both aquariums? What do I know? So do I know the goldfish is 189? What do I know about the guppy? 94 more. Well, if it's more, I have to have the 189 and the 94. This is a particularly tricky question if kids haven't seen them before. But as soon as they draw it, I'm not sure, actually at this point, I don't know what the question is yet. Thank you. This thing's quite large. Okay. So I don't know what the question is yet, but I have all my information laid out for me. Now I go back. How many liters of water are in both aquariums? I now know that I have to add 189 plus 189 plus 94. No? Goldfish have 189. The guppies have 94 more liters of water than the goldfish. So they have 189 and 94. So if I just did 189 plus 94, you're saying that the guppies only had 94. And this is a problem, especially where the visualization of it is so important. So there's your math, I would say. Now we need to do the arithmetic. How are we going to add 189 plus 189 plus 94? I'm going to show you another strategy that your kids use. You can start with 189 another 80. And they may count it up by tens. I got 8 tens. And I get to 369. I personally would go to 90 next and get 459. I'm sorry, I should be writing these up here. 100, 80, 90. I still need my 9 and my 4. Did I add something wrong? It's not the same answer I got earlier, is that right? 289, 69, 459, 8 more, and 4 more. So it's a number line. They still broke the numbers apart. And then, by choice, they picked up how they wanted to go along the number line, which again has been practiced a lot in class and shared strategies in class. We're worried, is my arithmetic well?
I don't know what's wrong. The number line seems a bit confusing.
Yeah. Okay, what confuses you
No,
about it?
I mean, breaking down all the, I mean, I default back to the column method, but it's, I don't know, the kids are practicing breaking down those numbers that,
The kids are very used to breaking these apart into 100 plus 80 plus 9. 100 plus 80 plus 9. Here, to me, this child, this child is probably a step ahead of this child, that they're seeing it in their head already, they're understanding the numbers, where this child is needing to see what's going on. Your child may never like the number line. We're going to ask them to practice it during the unit. By the time the assessment comes, they get to pick whatever strategy they want.
so column method goes away? Or
We will not be teaching column
at
method
all?
in third grade.
So we as parents should stay away.
Please don't. Now, and I say that, let's do the, let me see if the next one works. Let me move on. Again, you would have to answer your answer statement, that's very important. Let's move on to straight addition, and I'll show you. I'm still gonna go back to please do not teach the column method, they don't need it. But I want you to see what they're doing in class with numbers, and you're going to see why the column method will make so much sense to them because of the knowledge they've developed. So if we go to the place value chart, this is hundreds, tens, and ones. I think many kids by the end of school like to call it H2O. HTO, I think they call it. But it's hundreds, tens, ones. Can we add this? I'm going to break my 315 apart. I have 3 100s, I have 1 10, and 5 ones. They did this over and over again last year with manipulatives. In the classroom, the first time we're going through this, not the first time, there are always manipulatives on their table, but I'm not making kids use them. If kids can see this without the manipulatives, we're trying to move on. If a child is still making mistakes, I'm going to ask them to go back and build it. But we are moving on. They've had lots of practice with the manipulatives, they understand. So now we're going to add 63. This is the column method. It's just a visual. This is the visual of the column method. This is what we want them seeing.
So you would prefer the H2O chart still, rather than see, 315 plus 63 like this? You'd rather see the HTO than that?
I wouldn't accept that.
You wouldn't accept this? Okay.
I'm not excuse
Sure,
me.
that's fine, I just need to know.
Yeah, there's a column method. Kids are coming in from all over different schools. If they've been taught it, I am not going to say, no, that's wrong, because that's inaccurate. It is right. But I am going to make them show me why it works. It is harder to take the human brain likes efficiency. It's hard to take a child who already knows the column method and get them, and I use the word move backwards, and I don't like that, but it's hard to get them to move back to the representational to prove it. they just so believe it. And so that's why we ask you not to get ahead. We will get to the column method. This is the representation of the column method so they understand why it's working. This one isn't as fun because there's no regrouping. You can just add it up. In a few lessons, I think the teachers are going to expect this. There's 3 100s, 1 10, 5 ones, 6 10s, 3 ones. You can see where this is leading, but I'm still expecting this. This problem isn't really the issue, it's the next problem. So, I mean, these all add up. Is that 378? Okay, so 126. Show you what I do. I don't require kids, but any child that's making errors, I clump my numbers by 5s. They've been doing 5 frames since kindergarten. They recognize that. It's an organizational method that helps. If you've got a child this is hard for because of hand-eye motor skills, whatever, one, give them a bigger piece of paper. We don't care. We're not trying to make it super small. But clumping it into 5s, if a child is missing things, I'm going to ask them for that sort of organization that'll help them. But if the kid's doing it haphazard and it's easy for them, I'm going to leave them alone. I mean, I'll talk about the organization, but if they don't need it, nor do I. So on this one, we need to start regrouping. I'm going to take this 10, I have to move it over here and give it to the tens place. Think about your column method. That's that little 1 above, which isn't a 1, it's a 110. And then how many do I have? No, I don't need to regroup again. So now, as long as I've done my regrouping, does it matter whether I add the 1s or the 10s or the 100s first? It doesn't. That blew my mind when I found out it actually doesn't matter. But the regrouping will come along at some point in time. So I would have 6, and I think usually they're going to do this once they draw the line. It's 600 plus 60 plus 50, so we have 600, excuse me, 665. So your kids can understand and do this off or do it with numbers, and I put the column method right next to it and say nothing. I'd say, what? How do these things relate? What's same and what's different? And that shift to the column method is going to be nothing. We just don't have to do that in 3rd grade. We're going to wait till all the children. But I didn't start with the column method. I started with this picture. And again, it would be also later in the year, that's even a more direct link.
I was going to ask if because they want some inclination to do that already, or should I say, let's go back to the the more of the pictorial.
Yeah.
You're already fine. I just
Right.
want to.
We want this. At the very beginning, your teacher might want to double check that they understand where these numbers are coming from, so they might ask them to. By the end of the assessment, absolutely do it the way they want. They've got to understand that this is a place value chart, and that is saying 600s. So I would probably still end up asking the kids to write it out like this. And I'm not, I'm a little bit talking off the cuff there.
Sure.
If a kid can see it and get there, I'm going to want to make sure they understand it, but I'm not going to necessarily, I'm not trying to make kids prove steps all the time just to prove things. And sometimes we do want them to get to efficiency. Yes?
I just want to ask about the way you visualize them. Is it easier for the kids to see like 110 is like a bar or a stick, and for the hundreds like a square?
Right.
Otherwise they all look the same to me.
Right. This is actually a step beyond.
Okay, that was...
Yes. So he was asking about, I usually, they're practicing practically always blue. The hundreds block, the hundreds square, the tens stick, and the ones cube. We would be building with those along with this. That actually came before this. So now I'm taking a representational thing and you have to trust by place value what its value is. Where with the base 10 blocks, it's very visual. If a child is having trouble, I'm going to go back to those base 10 blocks, where it reminds them again and again, this is 10 tens, this is 1 10, and this is a single cube. Oh boy, okay, this is what I do. I get started talking. Let's do, you can probably guess how that one's gonna work. Let's do the subtraction here. I want you to try to work this out. Please draw it, not just use numbers. Work together. What's this gonna look like? Oh, I'm not gonna do that to you because I don't wanna lead you down the wrong path. In subtraction, am I going to draw 217? No, because they're being taken away. And I probably, the first go round with this, I've got those manipulatives out there. I'm not adding to it, I'm taking them away. So now I get to, I need to take away 7. Can I take away 7? So I have to break this apart, move it over here, and give myself 10 ones. Can I take away 7 now? Now I need to take away 1 10, and I need to take away 2 100s. This explains in column method why you took that 1 from the tens place and put the 10 ones in the ones place. Still have to add it up, hopefully correctly. I can't read my own writing over here. Showing you this method heavily today because it is the one that leads towards the column method. Are we still accepting number lines? Absolutely. For some kids, number lines are brilliant. What I'd like to show you, and I'm not thinking this through, the kids also learned, let's do this one. I'm sorry, we call it the arrow method. For particularly bright kids who already have really good number sense, who do really understand it in their heads and they're very flexible thinking. This method is giving them a picture to show us of what they're doing in their head. So if we start with 557, let's say I took away 6 first. I'm not sure why you would, but the child may have. Just as I took away 6, the next thing I had in my head was 551. Now I need to take away 20, and I have 531. The arrow method is really good, or this, for the child might have taken away 30. As I said, these are real flexible thinkers. They got 527, and then they added 4 back and got 531. Okay, so you want to do this one, the arrow method? So 374, what would you do first? Want to take away 200? So this is kind of a note keeping of the mental process you're going through. So I got 174. What do you want to do next?
Minus 10.
7.
Minus 10, so I get 180. I get 164. And then I'm down here. And then you could do minus 7. Some kids might do minus 4 to get to 160, minus 3 to get to 157. So the arrow method, I consider it stream of consciousness. The kids who particularly like it are the kids who do see these things in their head, but we're saying, but prove it to me. We're giving them an option. The important thing is that they're not using equal equals, because the habit, if they don't know, and at 8 years old they don't, they would write 374 minus 200 equals 174, minus 10 equals 164. We're now mathematically incorrect. Because you're saying that 374 minus 200 equals 157 in there. That is just mathematically incorrect, but that arrow way gets away from that. The arrow way, I have seen both incredibly struggling kids, this be their favorite way because they just think so differently. They're allowed to do it in the order they want to. They're allowed to go up and down. And up and down, or addition and subtraction on a number line gets confusing. So I've seen this work exceptionally well for the really high kids and for some of my struggling students. And again, it's because honestly, they just see these numbers in different orders than most of us do. The kids in the middle, yeah, they like it. You know, it's fine. To them, it looks like a number line. That's fine. I'm going to have to make editing things. I'm going to tell you the next two problems don't really add much to what we've talked about, so they can be your homework. You should have to draw some sort of representation that you understand the problem. Most likely when you get a tape diagram, there was nothing exceptional. But I did, I wish this got smaller. There we go. Have you seen these arrows yet? Have your kids been bringing home estimation? I'm not quite sure where they are in the unit. Rounding and estimation is a very important part of math. Rounding is what you do to be able to estimate. I would argue that kids this age should be estimating first. It's not that you get the answer and then round it. That really doesn't help you at all. We used to always see it with a horizontal line, yet the language usually talks about rounding up and rounding down. So we're now showing it both ways. We talk about the midpoint mark. So if we want to round 27 to the nearest 10, talk a lot about what is 27 between. It's between 20 and 30. What's the mid mark between 20 and 30? 25. Place 27 on the number line. Is it closer to 30 or is it closer to 20? Kids understand the rounding. Where they have the more difficulty is finding what is the two numbers it's between. So we just have to keep practicing that and that understanding of the place value. Well, I want to round 384 to the nearest 10. That means I'm using that tens. It's between 380 and 390. Always place the mid mark. 384 is here, so it's closer to 380. I don't care whether they use the horizontal or the vertical, but letting them practice with both for a little while is important. So round 419 to the nearest 100. Please go ahead and do that.
200.
Did you get the same answer? And I gave you the last one because it's the anomaly. What happens when it is exactly at the midpoint? And we just talked about it's the grammar of math. Somebody decided a long time ago that we round up. To my knowledge, that is true worldwide. I haven't heard of a system that uses it that rounds down, but we round it up. And it's just, that's one of the few things we ask them to just flat out know. We don't get to vote. Somebody got to vote a long time ago, rounding up one. So I'd like to get to the last page, because this is where it all comes together. And again, this is where I say this comes back to the mathematics. These are the type problems your kids are perfectly capable of doing. Yes, they might be challenging. When things get challenging, you need to draw it, you need to talk about it, you need to defend what you're doing, and that's why we have kids working together all the time. Sitting alone and doing it by themselves, they do what they can do, but they don't get stretched, and they also don't correct their own mistakes. So that is the value of the kids working together. It's not really just to keep the high kids busy. It's so that they can justify and explain their answers. So I'm looking at the clock. We're going to do this one. The doctor prescribed 175 milliliters of medicine on Monday, 256 milliliters on Tuesday. Estimate how much medicine he prescribed in both days. At the beginning of the unit, I am going to ask to see those arrows. By the end of the unit, I don't think they'll be asked to see them. So I think most kids are going to get to 200 plus 300. So it should be around 500 milliliters. Precisely how much medicine did he describe in both days? Model the problem with the tape diagram. This is a part whole. Part of the reason we asked for that tape diagram right there is to get the kids away from the estimation, to get them back to the problem. Because some kids are just used to just going, just solve the next thing, instead of thinking about what's being asked. So asking them to do this here gets them back to the original problem that had how do they call it? The accurate, the precise numbers. They're going to solve it some way. Number line, arrow method, place value method, that's up to them. They should get an answer of 431. Now I want to know, is it reasonable? We didn't round just for the fun of it or just to make the teacher happy. We estimated or we rounded up here so we can see, is our answer reasonable? I would expect a statement, yes, 431 is close to, and I'm being very bad, these should be labeled, these should be milliliters, is close to 500. We want that thought process. In 5th grade, I often made them draw an arrow so I knew they were thinking about it. And the next problem is pretty similar. It's a little bit higher level because of the way it's written. But it is 9 o'clock. Can I state one more thing about the back page, and then I'm totally available for questions. I would like you to go to the next page. For some of your kids, this is pretty straightforward and fairly easy. We don't go to bigger numbers. We don't move on to the next grade level, but we do want to keep them engaged and thinking and extending their thinking. These websites have a lot of logic. Well, the first one, mathplayground.com, excellent logic problems. A lot of them are spatial. A lot of them are just, I don't get, and the kids are going, well, you do this, this, and this. I'm like, if you say so. Because I didn't practice those things. Spatial reasoning is very mathematical. So this is a great way to extend your child. MathCats is just another good one. I like the mathactivities.net.art. That takes it a different direction. Your child might have more interest in that. I can completely vouch for the top 5. We have a new IT integrator in elementary, and she said Dreambox is the best thing on the computer. I trust her. She's a fabulous lady. It's a purchased account, and I don't have a child, so I don't have a purchased account yet. Actually, I've asked for one. I haven't gotten it. So I can highly recommend it based on somebody else's. She said it's phenomenal. She's worked with it for years, and her own daughter loved it. So if your child is finding this simple simple. Please don't belittle it. Say, yes, that's good. You've learned how to represent it. I'm really pleased with that, so let's go do some of this. Now, the very last page is, if you want to tell me how today went, but I'm also now available for questions. Yes?
Can I ask a question about the column? Not to go over and over, the non-column adding that we're not doing. But
Can I just tell you, we call that the place value method, or face value mat, I mean, I'm trying to think exactly what they call it. It's using a place value chart. Excuse me.
Okay. So visually, you want them to use the chart.
Yes,
But as they graduate, they can use the column with the actual numbers.
yes.
But as the numbers get larger and they carry over, how do you instruct?
Right, if you ended up with 16 tens in there,
Right.
I would expect them to mark it out, put a 6, draw an arrow, and put
Okay.
that 1 representing the 100 over in the hundreds place.
Okay.
Does that make sense?
Yeah, I mean, we would carry in
Yes.
our head.
Yeah, so let me see if I can do this. If I pick enough numbers, it will always work. So I got 17, and you know, where and when you do it is up to the child. Okay, so I can't leave this. This needs to become 7, with a 10 coming over here. I have 18. I can't leave this. I need to move it over here, and now I've got 987.
Okay. Perfect.
Yes?
Thank you.
Is it 431 nears to 400 or 500? Because sometimes in the units that my kids taking, if it's over 50, it's nears to 500 or it's 150.
Okay, so here's my arrow. You said 431?
Yes.
Here it is on my chart. Is it closer to 400 or is it closer to 500? 400. Here's your number. I mean, whenever that question comes up, I just come back. Let me, do you see why? She's referring to the last problem that we did. Did I say something wrong? Oh, because the last problem. We did not tell them, and this becomes a choice in 3rd grade. Are you rounding to the tens digit or are you rounding to the hundreds digit? Well, they go to thousands. I don't think so. So it becomes a choice, and there are going to be kids who want it more accurate. The truth is, in rounding and estimating, you usually round to the highest place value because you just don't have to be that close. I mean, you're just trying to see if it's close.
Yeah, because my kids, I have a child in 3rd grade in US, and sometimes he gets mistakes. Sometimes they say, when he puts to near to 100.
Okay.
Yeah.
And as they are learning the skill, we might be asking them round it to the tens sometimes, and then we may ask them to round to the hundreds. I'm trying to think, would you ever, never have completely different answers? Well, you could have 450 or you could have 500.
Yes, over 450.
Oh, I see what, now I'm here there. Thank you, I said that out loud. Because 431 goes to 450, then 450, if you're only looking at, see, you just have to go back to the original number. And if you put it on that line, you can see that it's closer to 400. We can't use the rounded up number to then decide where to go if we change the place value to hundreds. I'm now following what the question is. If I had gone to the tens place, 431 would round to 450. Now I have 450 and it would round to 500. The problem is we don't really ever ask them, you'd always go back to the original number, not a rounded number to find the next rounded number. Yes?
Since we do the midpoint, so if it's under the midpoint, then it's to the lower direction. And if it's above the midpoint, it's to the higher. So if it's 431, it is under the the 500, so I would have written, is your answer reasonable? I would have said no, because 431 is under the midpoint, and it's 500 mil that we're referring to, so is that just making it harder than it needs to be, or? If he would have said this, if my kiddo would have said the same thing, I was like, oh yeah, that makes sense to me, yeah, because it's, like, what would be considered unreasonable?
50. We're looking for magnitude. Within magnitude, that was pretty close. We're looking to see, did they lose the hundreds place? It is not a guarantee, rounding and estimating is not a guarantee that the answer is absolutely correct.
Yeah.
So when we talk about rounding, we talk about magnitude. Are they in the right, are they in hundreds, or are they in thousands, or are they in ones? It is as close as we can get. That is a tough skill at 8 years old. That reasonableness and understanding magnitude, and some kids being, I don't know, what is that, 71 off, might seem horrendous to them. And that's just the beginning process of understanding this. Can you answer that one any better than I
No, I
can?
just want to say a comment. No, you. Because I see it with my kid, and I've seen them doing this. For example, with this particular problem, we made a big deal out of it. So 175 by. It's very logical to round it to 100, so it's 200. But the 256, I think a child in 10th grade would say, maybe I should round it to the nearest 10.
And there
So
were-
you've got now here 200
Yeah.
and 250.
Yes.
That, sorry, 200. So it's 450, which
Yeah,
is
and
very
it would have been
close.
much closer,
You
yes.
see what- So they don't have to necessarily round to the same value, to
Yes.
the hundreds, and it could be combination.
Right, and kids will round differently. And I mean, we,
It's not only they run
to the 250, no, that is not wrong. In general, most
60,
people,
sorry.
especially 250, again, 50s are 50s are benchmark numbers, and so they may gravitate to that. If they rounded it, I'm trying to think of a different number, to 290, if it had been 289, I mean, that, you're barely helping yourself. Rounding should be able to be a mental arithmetic skill when you get the two numbers. So you don't want to get to 290 and 270 and still have to write it down. You would want to get to 300, I know that's 600. So,
The number is in the mid-mark, so we round it to the 80.
yes, and that's just one of the few rules we just have to teach. There's some grammar in math. It's the way it was decided, and we want to all do it the same way. Yes?
Just that I'm really confused because my daughter is doing timetables and the homework is like play outside. It's not on this.
Okay, thank you. This unit is just starting. I went through it.
It's just that decomposing numbers.
Okay. They're in addition right now. They're going back to multiplication again in the next one. Please don't go home and teach this all to your kids. They have not been exposed to it yet.
What happened what they did?
They did multiplication in the first unit with what we call the easier numbers, 2s, 3s, and 5s, and 10s. No, we didn't do a workshop. So yes, they could now,
Because this is like similar to what they did in second grade.
yes, and they'll be doing adding again in 4th grade. We're ramping it up. It is a degree higher. The numbers are much larger. No, this is probably just, we have this before so you can see it. This will be coming home in the next couple weeks, I promise. Or they may not send it home as homework, but they're doing it in class. So I scheduled this towards the beginning of the unit so that we would front load you guys, depending on the availability of the room. Sometimes it's right at the beginning, sometimes it's midway. Wait for another question about. Yes, there will be a multiplication one next time. Some of them, we do it for the real major units. Here, you and them.
She said the next one is multiplication.
Excuse me, I should take that down. If it goes to round 431 to the hundreds place value, it would go to 400.
Okay.
She was rounding it to the 50s mark, which some people use as a benchmark. So she took it up to 450. That was a choice she made that was probably a little bit more sophisticated than most kids would make. But some will.
But what's the answer?
They're both right. In estimating, yeah, they can both be right. We're just taking them to a different degree. I know. Well, math is no longer completely straightforward. No. Going to 400 is correct. prerogative of the child to decide on their benchmarks. Most would do exactly like you did.
But let's say they're doing sort of like a set test, there should be one answer.
They're not, on an SAT, they're never gonna, I can't say never, but I doubt that they're asking for estimates. Or they're going to say, if they ask the question, they are going to say, take it to the tens place. They're not gonna leave it up to you two. They're going to say, take it to the hundreds place. If it's on that sort of test, they will be very specific how they want it. Yeah. Can I come back?
You know, sorry, I just want to add, what we're doing right now is emphasizing the concept.
It always goes up.
rather than
When it's
doing
exactly in the
calculations. I don't
middle,
see
it
how
always
it
goes up.
works.
I'm thinking,